it. I mean, even doing what I was describing myself, like extending the conversation where I'm just like saying the first thing that comes to my mind, is also a strategy to like avoid saying, "Yeah, I guess I was wrong," and yeah, that makes sense what you're saying.
I I guess I can understand someone not wanting to have a prolonged conversation on a topic because I know some people say things to me and don't expect me to go, "Can you prove that?" Um,
That is one of your more annoying things, but it's a fair question.
which I prefer people to be accurate instead of being told something stupid without evidence. It's the reason I'm not religious.
Mm,
Um,
I mean,
but
you.
I know it can be, sometimes that's not the kind of conversation you want to have. Sometimes it's not
Sure.
the kind of conversation I want to have.
I mean, what if
So,
someone like reversed it on you and just said, "Please explain gravity if you believe in it, so be." And it's like, I don't need to explain gravity. It's out there. You bitch.
okay,
It's
so the way that one explains most scientific proven theories is essentially you make a prediction based on the theory, the way it says, and then you go and perform an experiment, and if the result of that experiment fits with the prediction, and you do that enough times, then it suggests that the theory must be true, or at least true to the scale that you're using it at. That's
um,
kind of the way that science works, which is really cool, I think. So the part of the reason we are so certain about our theories regarding like the Big Bang, the beginning of the universe, and the way that celestial bodies work is because we've made predictions using our models, and then we've used them to like, a planet should be there in this situation, or there should be cosmic background radiation that just exists. And when we go and check if the thing that we postulated exists, it does, and it's the place we said it should be. That means we were probably right.
it's just what God thought, surely. And
But
that's
I
what
just,
that's what the other side does. They just come up
yeah.
with another reason why they're right,
But I just, I didn't know for a long time that that was the scientific method because I never really looked into it. I just sort of, pretty much believed basic scientific facts on faith. And then when I found out about the way projections work, I'm like, that makes perfect fucking sense. That's really cool because you essentially because you make the prediction first and then test the validity later, it means that you can't be biased. If it works, it works. If it doesn't, it doesn't.
I'm sure. It's understandable. I'm only half paying attention, but it sounds absolutely right that theories based of theories that later on I found out to be true is quite gratifying to know that you weren't biased because they follow the thing instead of just what you believe to be right.
Yeah. Specifically, it's about predictions and proving them. No, nothing in science is considered like a strong theory unless you can make predictions and prove them.
Why is Joy to Pad missing? I is this can't be the first time I've recorded this on my computer. It must have got deleted somehow. Oh my god. Fine, I'll download the friggin' Joypad. Pirate Bay it is.
It's the reason why in a science lesson, quite often they will make you do these basic experiments related to whatever thing that it is that you're learning at the moment, so that you have for yourself seen the process of making a prediction and seeing if it comes out right.
Is that true? I mean, I've not really taught. I've been taught science in such a way, so
Ah, that's sad.
vaguely. Yeah, I don't think my school really encouraged that kind of thinking. They just wanted the basic English, maths, and I guess science, but I don't remember that much from science class. It's like maybe they taught the periodic table. Sure, no one fucking remembers any of it, but didn't go out and experiment with anything really.
Okay, do you know what the first element is on the periodic table?
Hydrogen.
Yes, good. That's the
I
second one.
oxygen. I don't fucking
No,
know.
no. Two hydrogen atoms, a helium atom,
Alrighty. Honestly,
basically.
I just guessed hydrogen. I'll
Yeah,
take the
hydrogen
win.
is the most abundant
Uh,
element in the
compound. Yeah,
universe
yeah.
because it is It's not a compound.
Is it not?
Um,
What's a compound? Is it a
a
combination?
compound is a combination of elements.
Mm.
Uh, but yeah, when you have what is it? Uh, like the atomic number is one, so like a single neutron and one electron. I can't remember the exact things, but basically the neutral state of an individual piece of matter is hydrogen.
Uh,
When you start adding further atoms, then it becomes heavier elements. But
no?
at the start, at the Big Bang, it's just like everything is just hydrogen. And then gravity pulls it all together and creates these big blobs that eventually become stars. And when there's enough force from gravity just pushing in on the middle, it essentially, like,
Ignorance?
this is oversimplification, but it pushes two hydrogen atoms together so much that they fuse and become helium. And that releases a shit ton of energy, which causes more stuff to fuse, and the whole thing continues. And that's why a star does that.
Yeah, I know.
Stars can continue doing that up until about iron. That's the heaviest element they can make, because at that point, it takes more energy to fuse than you get out of doing the fusion.
I'd seem to thought there was like stars that had cores made of like diamond and stuff that thick, but okay.
No, heavier elements only get created basically by supernovae, generally. I think ever so slightly they can fuse a small amount of iron just as a part of the natural process, but it usually stops there. But when the star collapses and breaks down, uh, it has that giant explosion of heat that basically it will combine things into much heavier elements, even if it is, um, not efficient in terms of fission versus fusion. And that's how planets end up with heavier elements than iron.
Oh yeah. I've definitely heard of planets with that diamond core I described, but I thought it also
I mean,
extended to
the,
the
the thing
stars.
about diamond is that it's just
Yeah, yeah.
carbon,
It's
which
not like
is
yeah.
uh,
I mean,
I can't remember what the atomic number of carbon is. I don't know if it's before or after iron.
you don't know.
I have to
There's
check.
there's things you don't know.
I don't know lots of things. I couldn't tell you most of the periodic table by heart. I never learned the Song of the Elements all the way through.
There's a song.
Yes, it's by Tom Lehrer.
Oh, I thought
Uh,
maybe the Animaniacs.
nope. It's to the tune of Modern Nation General, or whatever it is. Yeah, carbon's atomic number is 6, so yeah, a star can create that.
Hooray!
Just naturally.
Oh my god! Why am I having such trouble with this?
Yeah, and anything under the atomic number 26, so that's quite a few elements that can just be created in a normal star's life cycle.
I'm sorry. I'm just opening a file. Yeah, I'm not really absorbing a lot of that information. As I said, I learned like basic science stuff. Like the only other thing I can think of they taught us is like how circuits, like electrical circuits, worked, like plugs and whatnot. And it's like,
For all I know, you might know more about that than me. I never really enjoyed doing the circuit stuff for some reason.
mm,
Couldn't tell you why.
I probably know less than you. In all fairness, as I said, not properly taught. They were just kind of there for staying away from other people. But I'm not going to reflect on sadness. This is happy times. We've started the game again, so we could change
Ooh.
the subject at any time.
Do you know what nuclear fission is then?
It's the slamming atoms together to release a great deal of energy.
No, no, that's essentially fusion. You've described, kinda.
Oh,
Uh,
am I in the
fission
ballpark?
is fusion is combining atoms to create energy by pushing them together. Um, fission is separating atoms to create energy. Right. So you take a nice big heavy element like uranium. It's got a really high atomic number. Um, and then you bombard it with radiation, and basically that causes it to split.
I mean, radiation itself is some degree of particles, so
Not all particles, but in this case, yes. It's usually beta particles they use for this because they want a transfer of a single electron. Because the way certain
mm-hmm.
certain uranium atoms work is they are unstable and only need one electron to just go, that's it, I'm critical mass, I'm gonna expend all my energy and become smaller elements. And the release from that is some energy, yes, but also an extra electron, which could then pass to the next uranium element atom right next to it and do the same thing and create a big old chain reaction.
And
That's how you get a nuclear explosion.
And that's how power was made. No.
I mean, they literally use that to heat water and then use the steam to make turbines work.
Is that water even usable? Isn't it like highly irradiated?
Yeah, I mean, it's not so bad. Uh, can water even be irradiated?
I'm sure water could be irradiated. That's the whole plot of Fallout 3.
Fallout 3's plot is terrible.
I'm currently playing through Fallout 3 again, actually. So.
The big thing about radiation is that it specifically comes from like unstable particles, unstable atoms. Usually, if something like water is quote unquote irradiated, it's because there are radioactive salts in it, not because the water itself is radioactive. I'm not sure. I'd have to look into that. I've heard people say that you could essentially go for a swim in the water of a nuclear reactor and suffer no penalties, as long as you don't get within like 5 feet of the reactor itself. That is to say, the actual rods of uranium that are producing the
I mean, if that was true, you could just make like a dish of water to protect cities from radiation or something. Something like fucking Simpsons Dome it. Fucking. It can't be that simple.
There isn't really really a need to protect cities from radiation, so why would you even do that?
In the hypothetical chance of like nuclear fallout. But I'm saying like if that was the case, then you could just wear a sealed suit with a layer of water over it and just go right through a
No, it's the thing is, as I say, it's like 5 feet. So the different types of radiation have different penetrative qualities. So alpha radiation, which is basically a hydrogen particle, it's that big, that particular kind of radiation, that has awful penetration. That's the one where you can basically stop it with like a piece of paper. Beta radiation, which is a single electron, that's a lot more difficult to stop. That's the one where you typically want like lead. And then there's gamma radiation, and gamma radiation is a wave. So that one is really fucking difficult to stop. It's also the least harmful, but yeah, gamma waves are like everywhere.
Ow. Yeah, because I'm pretty sure like almost every electrical device gives off a small radiation wave or something like that. I've heard, but
well, I mean, fucking types of stone give off radiation.
Yeah.
If you live in a house with any granite furnishings, that tends to give off, if I recall correctly, beta. Yeah. But at a very low level amount. So most people, there's sort of like an inverse scale of like the more penetrative a type of radiation is, the less damage it will do to be around. So that is to say, alpha radiation has the potential to be the most damaging, but you basically need to ingest it for it to actually cause any damage. Like it's unlikely to get through your skin layer.